If you've been following this video series, services are talking to each other now. You've got some synchronous services, you've got some asynchronous services. They're all communicating with each other. And maybe some of you have ended up in this situation, and then someone says to you, how do you handle identity? Who is this user? What service is calling me? Should I trust it? Who knows? And suddenly you're looking at OIDC, OAuth, mTLS, API keys, bearer tokens, JW keys. It feels like a lot, doesn't it? So in this video, you're going to learn all about identity and how to manage it.
As always, I'm being the pragmatist here. And I think if you've got one simple deployable application, you shouldn't overthink it. All modern web frameworks have some built-in way of doing local auth. They probably use session cookies, a simple login flow with a little auto-generated login page. That's fine and secure and very easy to reason about. I think this is the default starting point for any modern application. Just use what comes with the framework. Typically batteries included, typically very straightforward.
Your pragmatism is making me sad, Scott, because I want to build a distributed system, please. And why aren't we starting with a big distributed identity thing?
Because we don't have a distributed system yet, and we don't have distributed identity problems yet, which makes everything a bunch easier, James.
But I want a distributed system, Scott. I love distributed systems. But genuinely, seriously now, we do have an element of multiple services, right? Like users are logging into something and then users are starting to access other bits of the system. So yes, while I completely agree with your point of start with one deployable app, deploy that to a serverless container, as we've talked about in other videos, like eventually you're probably going to get to a scale where you've got multiple things.
Yeah. So I guess if you really have to do that, and obviously in our case, we have had to do that. This is where things like open authentication and OpenID Connect are a really good choice. You let something like Auth0 or Okta handle the hard parts. Effectively, you delegate authentication and authorization management out to a third party, and you trust that they do that very well, so you don't have to handle credentials directly yourself. You get tokens in some form from them. You pass them along between your applications. Happy days.
And I think at least most programming languages that I've worked with have like libraries for doing this, both for like interacting with the token that Auth0 or Okta might distribute, or even, even in Stickerlandia, we don't necessarily use Auth0 or Okta, but we're not, we are still using a library of some kind. In the .NET world, there's a library called OpenID, which gives you an identity, which turns a ASP.NET web server, ASP.NET being the main web framework in .NET, for those of you who aren't .NET developers, into an identity server by basically adding these 4 lines of code. Now, there's lots of configuration inside here, but broadly speaking, you can just say, I want to add OpenID to my web server. I want to add the core functionality, and I want to turn this into an identity server. Equally, if you were building a client in .NET, you would do, I think it's add client. Let's have a look. Yeah, so you can do the same with the identity server and the identity client. So even if you don't want to adopt a third-party provider, there are probably libraries that you can use in your chosen programming language.
Exactly. And I think the big takeaway here is that you shouldn't really build identity yourself if you can all avoid it. In our case, I think we would have been pretty happy to use Auth0 or Okta or another one of those, except that we also want this to be runnable locally without a cloud provider at all. So you can run it in a data center, totally air-gapped from the internet if you really, really want to. And we've still been as pragmatic as we can. We've used OpenID so that we don't have to build all of the authentication infrastructure ourselves. We've picked the point on the spectrum that makes sense for our case without pulling too much into our own domain.
Yeah. So I guess the thing I'm thinking now, though, is that, we are in this position where we can't do a single deployable app. We've got multiple services, 4, maybe 5 at the minute. I can't remember exactly. So I guess what I'm thinking is like, do all of these services also have to deal with identity? Obviously, I've just shown some .NET code there for how to configure a server and a client. Like, does everything now need to have their own programming language specific implementation of that identity thing?
I don't think you really have to start with. You can kind of imagine typically you have often services that are public facing, things that users can call, things that users can access over the network. And obviously these have to authenticate identity in most cases in some fashion. So we'll assume we're validating tokens and whatnot over there. But it also happens that you often have services that are internal only, services that the front-end services call, services that might be exposed in internal networks in the business and internal networks in the cloud, what have you. I don't think you really need to go and handle tokens in those in the initial case. In many situations, you'll have to, because some element of the access granted to them will be a function of the user who is calling them. But in simpler cases, you simply don't. You trust the network to protect them. You deploy them in a fashion that they are physically not accessible, and you are happy. You constrain the spread of the authentication and authorization with your application in a pragmatic way to begin with, basically. You reduce the problem space.
So what I think I'm hearing you say is just trust the network, right?
Yeah, and I think that's fine. We've been doing that for lots of things for a long period of time. Certainly belts and braces is a thing, and that might not be something that you're comfortable with. And then you can add authentication and authorization to all of the services. It's kind of like a table stakes thing. But I don't think you have to.
I mean, I'm definitely all for keeping things as simple as possible, but equally, like, I'm sure one of the fallacies of distributed computing is the network can be trusted or something like that. But like, I can envisage a world where security teams don't like that. And back when I worked at AWS, I was consulting with a company who did like zero trust networking. And it took a lot of time to set them up, and it caused so many problems and frustrations just trying to get two services to talk to each other. But equally, like, I think even if you're making internal service to service calls, the service being called, I think, should have to prove who they are, right? Like, what if this, I'm building a service that's got sensitive information in it, customer information, PII, whatever. Surely I want to know who's calling me, surely.
Yeah, if you have that worldview, which may be a very reasonable worldview, James, then your services need identities as well, right? Not just your users, but your servers, so that the services know I'm being called by this other service. This is the identity of that service. And this is when things get more complicated. You start to talk about things like mutual TLS, bearer tokens for the services, things like that.
It sounds like you've just used three words, and I'm like, huh? What's Scott talking about now? It sounds like this is about to get more complex.
I think the easiest way to start with this these days, where you decide that all of your services should be authenticated when they call each other as well, is to basically use the same technology used everywhere also to authenticate your own users, which is OpenID Connect and OpenAuth. Basically, the idea is that we use flow facilitated by your regular ordinary identity provider that lets services go to them with their own credentials, some secret key and a secret identity name, and say, hey, please give me a temporary token and I want to use it to call this other service somewhere. This obviously adds more complexity to the services that are doing the calling because suddenly they have to have an identity to call things with. But in this case, the client credentials flow, which you would typically use for it, it's very simple. It's easy to reason about. Again, it's something where there are lots of different libraries to make this very easy for you on the caller side of things. There's also a nice symmetry there where if you are a service that consumes identity, if you're a thing that is authenticating calls to you, you can do it in the same fashion, regardless of whether or not a user is calling you or another service. You just make sure that the claims model, the set of facts about the principal that's calling you is consistent enough between the two that you accept the tokens regardless of how they've been issued to a person or to another service.
Cool. That makes sense. Now, you mentioned something else then. That all makes a lot of sense. And I like the idea of we implement auth once and we just be called by a thing, whether that's a user or a service, right? But you mentioned mutual TLS or mTLS. Like, what the heck is that?
So TLS, transport layer security, is the presentation layer thing that you use to do SSL when you hit websites, your HTTPS, stickerlandia.com or what have you. You are encrypted to the server. And as part of that exchange, when you talk to the server, you are validating that the server is who they say they are. So if you connect to stickerlandia.com, your browser is ensuring that it trusts that that certificate has been issued to somebody who can act as stickerlandia.com. So you have one-way TLS there, right? Or one-way authentication as part of the TLS. Within HTTPS and within TLS in particular, you can also do it both ways. So the server can validate your identity. The server can say, I only trust people to connect to me and use this endpoint who can present a certificate signed by this certificate authority.
Yeah.
This is something that people use for a long time for service-to-service authentication before we went so crazy with OIDC and OAuth everywhere, where you have some internal certificate authority that issues certificate information to all of your services. And when they connect to other services, they use that to prove that they are allowed to connect to that other service. It works very well. It's something that's used pretty widely also in service meshes these days. You often say, if you're in Kubernetes service mesh land, hey, only allow these to connect to each other if they have mTLS enabled. And it's a good way of doing point-to-point authentication in that fashion. You can mix it with regular OAuth OIDC. You can say that we can authenticate this way or that way. You can say service to service is mTLS. user to service is with tokens. There's a lot of options there. I tend to think that using tokens everywhere and OIDC everywhere is a bit simpler, but horses for courses.
It sounds like mTLS means managing certificates and passing certificates around, and like that. That's how I understand what you just said, right? Like the service, the caller, and the callee, you would need a certificate that can then be validated in both directions. That does sound confusing and complex. When you've used the word tokens quite a few times now, that seems like it's not as simple just to use tokens. But at least when I've looked into this kind of thing before, there seems to be lots of different types of tokens, and honestly, it confuses the heck out of me. Like there's different ways, even within what is sounds simple as let's just use tokens, also can have an element of complexity to it as well.
Yeah, for sure. And I did brush over that a bit in your defense. There's kind of like at a high level, two different classes of tokens. There's opaque tokens or bearer tokens, where the token is essentially just some random string that's pretty long. And you can't tell anything about the person who presents the token, or even if the token is valid. You have to go, if I am a service that is being called with that token, I have to go back to the identity provider with the token and say, is this token valid? And can you tell me things about the person who is presenting the token, at which point they'll return the claims model, like this is the username, this is their identifier, rah, rah, rah. So you call me, I go and check, is the token valid? It says good, we're good. The other option, which is more popular with web apps these days, I would say, is JavaScript web tokens, which is basically a big long string again, but somewhat longer than a bearer token, where it's basically a base64 encoded signed JSON document that tells you about the user. So your identity provider produces this document that has a bunch of facts about the user. It signs it with its signing identity, and then the user is given that token, which they can present to things. A nice property of JWTs is that you don't have to call back to the identity provider for every JWT to check it. When you've started up, you've gone to the identity provider, you've got their public certificate, and you can use that to validate that any token that's presented to you has been produced by them, which is cool because it moves the identity provider out of the latency path. It's also cool because you can grab a JWT as like a regular user, and in most cases go and decode it and see some fun facts about yourself, which is helpful to the development a bit, I think. One downside is that they're effectively non-revocable. If you have a bearer token, you can choose to revoke it. You can go to the identity provider and say, this is no longer valid. And then when services call back to the identity provider and say, hey, is this bearer token good? Which they have to do to check that it's a valid token. You can say no. Because a JWT is a standalone thing. Once you have it, it's valid for a period of time. It's non-revocable, essentially. To do, James and Scott, check that there's not some common mechanism for revoking JWTs. I think you have to do it ad hoc, but this might have changed a little bit. So I tend to be partial to JWTs. I think they're kind of like a good default choice these days. But again, either one of these will work well. And in both cases, they're supported by the underlying machinery of OIDC.
And even if you were using the certificate auth thing with the same kind of thing, I guess the certificate auth is more like service to service, right? So that's not as relevant here, I suppose.
You can absolutely do certificate auth for browser to service. And this is a thing you used to see in some enterprise environments where client certificates would be shipped to your browser and then you would need it to connect to certain internal things, but it's not very common anymore.
Or at least I've connected to something that needed me to do some weird certificate stuff locally, I think. Yeah. Anyway.
You don't see it much anymore, but it used to be a thing, yeah.
So that was a whistle-stop tour through like identity and different things. And it feels like there's an element of pragmatism, but also once you start to walk down this road, the complexity soon rears its ugly head. So what are the really concrete things that if someone's listening to this and they're like, okay, I need to do identity, like what should they do tomorrow, today?
I think first point is keep it as simple as you can. If you have a single application, a single web app, use whatever the built-in authentication authorization framework there is. Inevitably, lots of effort has been sunk into making this very easy to use, which is good, very robust, which is also good. If you need distributed identity because you're in microservices, you have multiple individual deployable components that talk to each other, I think you should probably start looking at OIDC and OAuth to start with there, and you should probably use one of the SaaS providers to delegate the auth problem out to. Most people are doing that these days, or lots and lots of people. It's like a very robust, relatively straightforward way to get things going, and it means that you own the smallest amount of code and application infrastructure around identity yourself. For service-to-service communications, I think you have this choice between using OAuth, IDC there as well, or using mTLS.
Or trust the network.
Or trust the network, yeah. And like honestly, I think that's fine in lots of cases. But Obviously, people have different risk tolerances there. Here as well, I think it's nice to use the same technology everywhere. I think generally OIDC Auth for service to service makes things easier to reason about. mTLS is great. It's cool tech. You see it a lot with service meshes. If you're doing service mesh things, maybe you would just use that for service to service auth. Otherwise, again, I think it makes sense to just keep things consistent, regardless of whether a user is calling your service or a service is calling your service. Present the same thing, validate the same thing.
That definitely sounds like the simplest option of the complexity that we started to toe into here. And if you are interested in seeing any of this in action, whilst we don't have mTLS in Stickerlandia because you can see a lot of this in action if you go and have a look at the Stickerlandia repo. As always, there's links in the description below. We'll put links to specific pieces of the code base to actually go and see some of this in action. There's CDK, there's Terraform, there's shared constructs that demonstrate how to set all of this up, all in one easily deployable repo. And with that, we'll see you in the next one.